Number 6, graph the function, and again we have ourselves a piecewise function. We have f of x equals -5 if x is greater than or equal to 1, and f of x equals -1 minus x if x is less than 1. You can see that we have two xy tables, and I would recommend you create an xy table for every piece of your piecewise function. So we have two pieces, and so we have two tables. If we had three pieces, you would have three tables, and so on. This first table here, f of x equals -5, is for the first piece. F of x equals -1 minus x is for the second piece. And notice that the domain restrictions for both pieces here revolve around +1. So we're going to let +1 be the first x entry for each of our tables. And then from there, we'll use the inequality, the domain restriction, to help us find the remaining x values. So f of x equals -5. The domain restriction for this piece is x is greater than or equal to 1. So what are some numbers greater than 1? Well, 2, 3, 4. And let's find the corresponding y values for each of these x's. We want to find f of 1. So we're going to take 1, plug it in, and see what happens. But notice that here we have f of x equals -5. There's no x variable for us to plug anything into. It's simply a -5. So what this is telling us is that this is a constant function. No matter what the x value is, we're always going to have the y value be -5. And so that's the constant part of this function. It's constantly -5 at the y component for the ordered pair. All right, let's find out what the points for the second table are. Well, again, our domain restriction revolved around +1, so we started at 1, and from there we're interested in x values that are less than 1. So how about 0, -1, and -2? To find the corresponding y values, we know we're going to plug in each of these x values. So we're going to find f of +1 equals -1 minus x, -1 minus x, and we're saying x is 1. Let's distribute, so we end up with -1 minus 1. This gives us -2. All right, let's find what the corresponding y value is when x is 0. So we're finding f of 0. That's -1 minus 0. We know this is going to go away, and so we're left with just -1. How about when x is -1? Let's see. So f of -1, we'll plug that in. So we have -1 minus -1. When we distribute, we have -1 plus 1. So we have 0. And we would expect then this last y to be +1. Notice that as the x value decreases by 1, the y value is increasing by 1. And you can verify that on your own by plugging in -2 and seeing what you get. Let's go ahead now and graph. Let's plot each of these points. We have to be careful here and remember what these inequalities mean, because at the point 1, -5, since that point comes from the first piece of our function and the domain restriction here, the inequality was greater than or equal to, remember, we've got to plot this particular point with a closed circle. Recall that less than or equal to, greater than or equal to, you graph with a closed circle. If it's just less than or greater than, you graph those points with an open circle. All right, so 1, -5, we will graph with a closed circle. 2, -5, 3, -5, 4, -5. All right, and so we can see the graph is constant at that piece. Let's graph now 1, -2, and because the domain restriction here was simply a less than, we're going to graph this point, with an open circle. So 1, -2, we'll graph with an open circle. 0, -1, so 0, -1, -1, 0, -2, +1, and so we have the graph looking something like that. All right, so two pieces to this function. We have a jump in the graph here, a discontinuity here in the graph. Make sure that you're paying attention to the inequality symbol used. Less than or equal to, greater than or equal to. you need to plot that particular point with a closed circle. If it's just a less than or greater than, you're plotting with an open circle. All right, but there's number 6. We graphed our piecewise function. Let's take a look at number 7. I'll see you there.